I know this is a little while ago, but how do we do this? How do we break this up?
Sine 10x squared, and then the 5x.
Yeah, so you need to realize that this sine squared, which I guess after doing the chain rule, maybe it's stuck in your head, but this sine squared means sine 10x times sine 10x, right? That's one way to think of it. And then this guy on the bottom, I would probably split him up. You can put the 5 with one of them and put an x here. So you have to do this limit as x goes to 0. So in order for this limit to be 1, these have to match. Same thing here. So I'm going to have to put a 2 down at the bottom for this guy, which means a 2 up at the top, which the top 2 is eventually going to come out. And then the 10 comes down here, so a 10 comes up on top, which is eventually going to come out as well. So on the outside, you have 2 times 10, which is 20, or limit, and then on the inside, you have sine 10x over 10x. You have 2 of those, but it doesn't matter.
That's one way.
So each of these goes to 1, and you get 20.
I pulled out a 1/5 in the beginning, and then did it that way.
Yeah, you can do it that way too.
Yeah, you can pull the 1/5 out at the beginning. Sure.
And then I get 100 in it, then I divide it by 5 and I get 25.
20. 100
No,
divided by 5, 20.
I mean, if you pull the 5 out in the beginning, then you'd have to do 10 here and 10 here, but there's a 5 out still.
Right.
So it'd be 100 over 5.
Got it. Thank you.
Yeah, I did that.
And you got 20, right?
Yeah, that's right. And then when I worked it with her, we did it that way.
And you got 20.
Yeah.
Perfect.
Don't matter.
All right, what else? What other questions can I help you with? Yes.
For the graph of the function, why does it cross -1?
So I think, are you talking about number 5 on the quiz? So from the quiz that I just, this was number 1, but number 5 on the quiz that I just passed back, I gave you the sketch of this graph here. It looks something like 1, 1, 1, 2, 3, 2. So something like this. This was F, and I wanted you to sketch F prime for me. So when you sketch F prime, what do you focus on?
Where m is 0.
Yeah, where the slope is 0. That's one good place to start. So right here, right, the 0 slope is going to occur at these turnaround points, the relative max and relative min. So right here and right here, m is 0. So you have to push that back to the corresponding x values. Here, x is 1, -1 I mean. And right here, x is 2. So on your derivative graph, when x is -1, because this slope is 0, on the derivative you're going to have an x-intercept. And then at 2, because the slope is 0, you're going to have an x-intercept. So the -1 and the 2 come from where the slope is 0. And then you go in and you analyze the slope. Here this slope is positive. Here the slope is negative. And here the slope is positive. So your derivative function is going to have a positive y value, then a negative y value, then a positive y value. So positive, then negative, then positive. So anything like this was good for the derivative. As long as you, I did make sure you went through these 2 points for the x-intercepts because that comes from the original.
I thought that was kind of cool. If you were graphing a function from like 126, if you took the derivative of it, because we just drew like a squiggle, we'd actually know where the.
Yeah, now in chapter 3, what we're going to do is go in and instead of drawing traffic squiggles like you did in 126, we're going to find where all the relative maxes are to get really nice looking graphs.
Yeah, that's cool.
What else can I do for you? the x-axis and the slope. That's what this is going to use.
If no one have a question, can I give you one that I didn't know how to get a derivative of?
Sure.
It's y.
So let's see. Was it one that you just came up with, or was it from a particular assignment?
It's from just like notes from CSN website.
Oh, okay. All right, sure. So just example then. Y equals.
No, y minus.
Oh,
Y equals
oh, Y equals.
27 x times x minus 3 inside the all cubed.
Like this?
Yeah. I didn't know where to start from. I know it's the chain rule, but it's like,
Okay. So if we want to take the derivative of this, there's a couple of things going on here. Yeah, one thing is that there's a product, right? So if I were taking the derivative of this, I would start with the product because I can break this product into f and g. So I would actually start with the product rule here. Within the product rule, you might need to use the chain rule, but sort of the outermost operation is a product.
okay.
So I'm going to start with my product rule, f of x equals 27x. G of x equals x minus 3 cubed. Then I do the derivatives of each of these. F prime is what? 27. G prime. Now this is where you might need the chain rule. Actually, you don't, but let's do it with the chain rule because it looks like you have an inside and an outside. Right, remember the chain rule you use when you have an inside function and an outside function. In this case, the cubed power is my outside function. So when I start doing the derivative by the chain rule, that cube comes down. Right, so when I derive the cube power, the cube function, I get 3, keep the inside the same, but then drop the power by 1. Right, that's what the power rule tells me. Times the derivative of the inside,
1.
which is just 1 in this case. So the chain rule is kind of overkill here. But when you do the derivative of the inside, the derivative of x is 1, so you just put times 1 there. Then you can use your product rule. Right? Multiply these, and add. So y prime will equal 27 times x minus 3 cubed plus 27x times 3x minus 3 squared. I didn't write this 1 because 1 times anything is the same thing, so you don't need to write it. Okie dokie. This is unsimplified, and I would actually like to teach you, or at least get you started thinking about how to simplify this kind of quickly.
X minus
That's where
3.
that's stuck.
One way you can simplify this, and one way that's going to be very useful in chapter 3 is to factor. Okay? Before that, though, let me go ahead and multiply this out. So y prime is 27x minus 3 cubed, but then instead of 27x times 3, let me write 81x. That's okay? And then I'm going to look on each side of this plus sign for the biggest common factor I can pull out. So for example, 27 and 81 have 27 in common, right?
Yeah.
And then what about x minus 3 cubed and x minus 3 squared?
X minus 3 squared.
All right, so out of these two, I can pull an x minus 3 squared. So this is just kind of scratch work. And out of this guy, I can pull a 27. So what that's going to give me I take my 27x minus 3 squared out front, and then I write my leftover garbage. So if I take 27 out, the whole 27 is gone.
X minus 3.
And if I take x minus 3 squared out, I just have x minus 3 to the first left. Right? You're going to subtract from the exponent. There's not even a real reason to write the first power because that doesn't change anything. But I'm just showing you that we subtracted the exponents here. Now here, when you take 27 out of 81, you're left with 3, and then the x doesn't go anywhere. But if you take this out of this, you're left with, it's gone, right? 1.
Yeah.
So then we end these. And because this is to the first power, we have one more step. Yeah, this is really just x minus 3 plus 3x.
4x minus 3.
So when you combine the 3x and the x, you get 4x minus 3. We'll put right. When you start finding the zeros of your derivative, right, which is what we're going to do in chapter 3 a lot, when you set your derivative equal to 0, it's going to be very helpful to have a factor. Right, because to set this equal to 0 is very easy. You just take the first factor, set it to 0, second factor, set it to 0, that's it. So being able to factor these derivatives is going to come in handy. What else? No chain rule questions? You guys did them all? They're all easy? Or you did none of them and have no idea? That's what I'm getting. It's one or the other.
47 and 55. Probably some more, but
Let's start with
I
those.
didn't get through.
47 sounds pretty far.
Not when it goes to 128.
Alright. Are you a pessimist over here? You're not on like 1, right?
Sure.
Ooh, I like 47. Ooh, I like 55 too. Alright. Those are acceptable questions. Saves me the trouble of making a review exam. So number 47. Let's see, so it's sine of pi x squared. Sine of pi x. And we want to probably, let's see, find the derivative. So first question, what is this, where does this squared go? Is it going to the sine or is it just going to the pi x? Just the pi x. Right, there's a difference between, right, sine squared pi x versus sine pi x squared. This squared only applies to the pi x, whereas this squared applies to the entire, this guy would be like this. Okay, so be careful, make sure you know which one you're working with. So then to do the derivative, I have to figure out inside and outside. So let's start first with the outermost function. What's the last thing? What's the last function being done here? Sine is outside. And all of this junk is inside.
Cosine.
So when you do the derivative, you do the derivative of the outside. The derivative of sine is cosine, but you keep the inside the same. So like this, times the derivative of the inside. Now be careful, this inside, pi x squared, is another composition. Okay? There is another inside and another outside. This guy here is out, and this guy here is in. So you have to do another chain rule. It's a chain rule within a chain rule. Which are my favorite questions from this section, probably, so hopefully this sinks in. So now that I'm doing the derivative of the purple box, the derivative of the inside, I have to start at the squaring part. So to do the derivative of the square, you bring the 2 down, write the exact same inside function. So I'm going to rewrite pi x, and then take it to the first power, 10. Right? That's the power rule. 2 comes down, we subtract 1 from the power. Times what? derivative of the inside, which is pi.
Wow.
So really you have 2 pi squared x cos pi x squared. This could, yeah. You could have done this without doing a triple chain rule if you did a little bit of simplification first. Or I guess a double chain rule. Right, the other way to do this, which, I mean, it's up to you, whichever one you like more, but you can do a little bit of an algebra simplification here by rewriting the inside as sine pi squared x squared. So then you have this outside and this guy inside. So when you do the, you still have to do a single chain rule, you'll still do y prime, but the derivative of sine is cosine. Recopy this times what? How do you take the derivative of this inside now? Yeah, this is a constant, right? Pi squared is a constant, so it just gets multiplied. So you write 2, because it comes down in front, pi squared x. So this part's right here, and then this is the same as this. I don't know which way you should do it. You should do it whichever way makes more sense to you, I think. You have to be really careful, though. If I change this from multiplication to addition, then you can't do any algebra simplification.
Let's just do it.
Right? If I put a plus in here, you cannot do any algebra simplification first.
Okay. Can we do it, please?
Couldn't do like pi squared plus 2 pi.
Yeah. So let me make it a little more complicated. Y equals sine of pi plus 3x squared. And then we'll put a big outside.
Nice.
So you can't, my original point before I started this problem is that there's a plus here. There's no algebra simplification. Well, I mean, if you wanted to simplify this using algebra, you would have to do pi plus 3x squared times pi plus 3x squared times pi plus 3x. You'd have to FOIL. You'd have to distribute 5 different things. So I would definitely not do any algebra simplification here and go straight to the chain. Right, this is my outside. This whole thing is my inside to begin with. So I do the derivative of the outside, which is cosine. Keep the inside exactly the same. Still to the 5th, because I'm doing the derivative of this. Times, now when I do the derivative of the inside, I have to break that apart again.
Into in and out.
Into in and out. So now the out will be the 5th power, and the in will be this part. So to do the derivative of a 5th power, which is where I start, I bring the 5 down, recopy what was in the parentheses, and then I do to the
Out of 4.
4th, right? That's the way your power rule works, you subtract 1.
Then the derivative of the inside.
Times the derivative of the inside. So times pi, when you drive pi, it's just 0, so get rid of that. But times 3x squared derivative, yeah, so the derivative of 3x squared is 6x. Y prime is equal to 30, because these can be multiplied, x pi plus 3x squared to the 4th times cos pi 3x pi plus 3x.
Very good.
You know why I rewrite it like this always? How come I move these in front?
So we don't mistake that it's inside the angle.
The way it's written, it's possible, although not likely, that you might mistake that this 5 times pi plus 3x squared, that this part is inside the cosine. But if I write it out in front, then it's obvious this is the only thing inside the coastal. Look at number 55. So f of theta equals tan squared of 5 theta. So this is another, technically speaking, this is another double changing. So what's that tan squared mean? What should I rewrite that as? Yeah, so immediately I want to recognize that square as tan of 5 theta squared. And then to proceed, to do the derivative, I'm going to break it into inside and outside. This guy's out, this guy's in. So when I do my derivative, f prime of theta, the 2 comes down, then I recopy the inside. It would be to the first power, right? But I won't even write it. Times the derivative of the inside. Now here's where you have to be careful. The inside has another chain rule. Because this is an outer function, and this is your inner function. So when you do the derivative of the blue inside, you have to do first the derivative of the green outside. So the derivative of tangent is, now should I write secant squared, what should I put in it?
5 theta.
5 theta stays inside.
Times 5.
Times the derivative of the inside, well the derivative of 5 theta is just 5. So 2 and 5 are coefficients when we multiply them together out front. Then you have tan 5 theta times secant. What else can I do it for? Okay. So next time I'll give you a quiz for take home. You'll take it home over spring break, I guess, and let it sit in your backpack for 9 days until the night before, maybe, and work it out, or the hour before, maybe. But I'll give you a take-home quiz on Wednesday. We'll probably do over to 2.5, so we'll cover 2.5 today, so that'll be on the